Hey guys, Mr. Backerberg here. In this video we're going to look at graphs of logarithmic functions. So as we're looking at the graph of logarithmic functions, we're going to focus on the natural log. So this graph that you're seeing is for the function f of x equals the natural log of x. Now as far as the domain of our function, we cannot evaluate negative numbers. So the domain for this function is going to be from 0 up to infinity. And the range of our function is going to be from negative infinity up to positive infinity. It might look like this line is starting to level out, but it does keep going up forever and ever and ever. This graph is continuous, meaning that we can draw out its entire line without needing to pick up our pencil. It's also always increasing. As we read our graph from the left to the right, it's always going up. Because this graph keeps going up, there are no horizontal asymptotes, but there is a vertical asymptote along x equals 0. Now we're going to look at some transformations of logarithmic graphs. So we're going to think about our general logarithmic functions. So either just y equals the natural log of x or y equals log base 10 of x. And we're going to perform some transformations with those. So let's first think about the function g of x equals the natural log of x plus 2. And we want to think about how would that plus 2 affect the graph of our function. And because that plus 2 is happening inside of the parentheses directly to the x, then that's going to be a horizontal shift. And horizontal shifts are always backwards of the way that you think they would be. So this actually moves us left 2 spaces. Or if we wanted to think about the function h of x equals log of x plus 1. This plus 1 is not happening inside of the parentheses. It's not happening directly to the x. It's happening to the entire logarithmic function. So this is going to be a vertical shift up 1 space. If we were given something like j of x equals 3 log of x, that 3 multiplier in the front is going to be a vertical stretch by a factor of 3. And if we wanted to look at one more, let's say we had the function k of x, and that's going to be the natural log of 3 minus x. Now this is written a little bit out of order, so we can think about it as the natural log of negative x plus 3. That plus 3 inside of the parentheses is going to move our graph left 3 spaces. But then putting that negative on that x is a y-axis reflection. Now this one's a little bit tricky. We're moving left 3 spaces and then we're reflecting our graph around the y-axis. So if we were to check this on our calculator, it would actually look like our graph got moved to the right by 3 spaces. That's going to be it for this video. Thanks for watching.